In this video, we're going to look at using Spearman's Rank Correlation Coefficient, looking at a past paper question. So what we have is we have a table of data here where we have some retail prices and mortgage rates. Now, because Spearman's correlation is a rank correlation, we have to rank our data. So first of all, we're going to rank, we'll have two more tables in our column. So we'll have the rank of retail price, and we'll have rank of mortgage. So we have to rank the first two columns from high to low. So the highest number we're going to give the rank 1, the lowest number we're going to give the rank, in this case 11, because there's 11 pieces of data. Well, the retail price one is already sorted, it's in descending order. So the highest one is going to be rank 1, and so on, 1, 2, 3, 4, all the way up to 11. So our lowest number, the 2.9%, will get rank 11. We'll have to now rank the mortgage rates. Now this is a bit harder because they're not in rank order. So let's have a look. The highest number, the highest mortgage number is this 7.27. So that's going to be given rank 1. Then the next one I think is this 5.71. Sorry, no, it's not. There's a 5.83 is higher. So that's our next number, 5.83. Then 5.71. Then 5.7. 5.67. This should be given rank 5. Rank 6 is going to go to 5.66. Rank 7 here. Rank 8, 9, 10, 11. So it's pretty straightforward. I just have to fill in the ranks. And now I'm going to create a column which is, we'll just label D as the difference between the ranks. Now it doesn't matter actually. You just need the positive value of the difference between the ranks. The difference between 1 and 3 is 2. The difference between 2 and 7 is 5. The difference between 3 and 2 is 1. And so on. We just need the positive value of the difference. And 3. Okay, and we're going to also create a column which is d squared, the square of these differences. So 4, 25, 1, 4, 25, 9, 16, 49, 16, 36, and 9. And that's the sort of table set up in order to use the formula. The formula is given in the top right, this 1 minus 6 times the sum of d squared divided by n squared minus 1. Well, n is the number of data points, so in our example, n is 11. And this thing, sum of d squared, is the total of the d squared column. So it's 4 plus 25 plus 1 plus 4, and so on. We're going to add all these things together, including all the way up to the last one, which is 9. So if we add all of those together, I think we get 194. Okay, so all we do now is we plug these numbers into the formula. The correlation coefficient, which we usually use R for correlation coefficient, is 1 minus 6 times the sum of d squared, that's 6 times 194, over n, well that's 11, times 11 squared minus 1. Okay, that's the same as 1 minus 6 times 194 on the top, and on the bottom we get 11 times 120. Okay. And it's important that you don't get the 1 inside the fraction. It's outside, so this turns into 1 minus 0.882, which is 0.118. Now it's always worth looking at this number that we get at the end. So correlation coefficient will always be between minus 1 and 1. So if you get anything outside of that range, you've made a mistake. If it's close to minus 1, that means a strong negative correlation. If it's close to 1, it means a strong positive correlation. If it's close to 0, it means no correlation. In this example, because 0.118 is close to 0, that means there's no correlation between these two variables.